All right. So today we're going to be multiplying, dividing. We're also going to be adding and subtracting rational expressions. There are not equations yet because there's no equal sign. So these are individual ratios. We're going to be handling them individually and together. So things you have to remember is that order of operations, multiplication and division both have the exact same priority. So as a result, we just handle them left to right. So the reason why I have all these arrows here is because when we're going to be dividing, we're going to apply the keep, change, flip order, where we keep these because we're multiplying them. And we're going to change the operator to multiplication. We're going to multiply it by the reciprocal. We're going to flip. We're going to keep these. We're going to change this to multiplication, and we're going to flip that ratio right there. So now we can look at the individual numerators and denominators. Let's look at this one. We realize that we can factor out a y, and when we factor out a y, we get x minus y left over. We see we can factor out an x here, and we get x minus 1. We look right here, x squared plus xy, and we realize we can factor out an x and get x plus y. We look at the denominator here, and we realize we can factor out a y and get x minus y. And then this denominator, which is going to become the numerator here, we can factor out an x and get x minus y. And this is going to become the denominator. We're going to factor out a y, and we'll get x plus y. All right, so now we're actually ready to do a little bit of canceling. We understand that all of these elements not only are they commutative, but we can see that once we have one element over itself, that's equal to 1, so we can cancel them out. So let's start applying that. We see a y here and a y here, so they cancel each other out. We see an x minus y and an x minus y, so they cancel each other out. We see an x and an x. We see x plus y, and we see it down here, so yes, we can get rid of them too. And then do we see anything else? We have x, don't have any more x's all by themselves. This is all exactly the same. Now, I know that I didn't want you to think that I canceled out that y. So what we have is x times x minus y all over y times x minus 1. You could write it this way, but I have to admit you should expand it sufficiently or distribute it. So this turns into xy minus y. And there's your final answer. So that's the last of the multiplication and division that we're going to do. Now we're going to go back to the principle of adding and subtracting here in 7-8. So not all of this is in my field of vision. That's okay. I can work with this. All right. So what we remember about adding is that we have to find a common denominator. And once we find a common denominator, sometimes it's a least common multiple. Here, the least common multiple is 8, right? The least common multiple here is 12 as well, but it requires me to change both of them. And in order to transform them without losing the integrity of the ratio itself, the proportion, we have to multiply them by a version of 1. So here, we know that we need to change this to 12. We need to multiply this by 3, but if we multiply one side, we have to multiply the other side of the equation by 3. So after doing that, we realize that we get 9 plus 8 all over 12, which turns out to be 17 over 12. And similarly, we only have to transform one of these ratios so that we can add them together with a common denominator. That's your review as far as the real basics are concerned. Now let's apply it to 7-8 here with one of your problems, problem number 10. So the expression that we have is x plus 3 over x minus 3 and we're taking away x minus 3 over x plus 3. You notice that we have conjugates, but the reciprocal conjugates here. Now, what we'll end up doing is, just like one of the earlier circumstances, we're going to multiply these two together in order to get a common denominator. So this side of the equation I'm going to have to multiply by x plus 3 over x plus 3. And this side of the expression we're going to have to multiply by x minus 3. So x minus 3 over x minus 3. And once we do that, this is all just in the same color, so that's a little bit easier for you to understand. We are going to have x plus 3 squared. This is x minus 3 squared. And then we'll have these conjugates finally multiply by each other. And if we remember correctly, when we multiply those conjugates from factoring, we know that this is a factored form of a difference of squares. So well, I've just done some of the math here of foiling out each of these sets of binomials. So we understand that the denominator is going to end up being a difference of squares here. Well, actually, let's just do the intermediate location here. And then if we look at x plus 3 squared, that turns into x squared plus 6x plus 9. But if we remember, we're doing subtraction here, and we've got to apply it to this entire numerator, which means that we're going to end up having to change the signs on every single element after we've FOILed. So what we have in the numerator expanded is x squared plus 6x plus 9, and then we're going to change each of these, the signs on this, minus x squared plus 6x, and then minus 9. Here, let's get that glare out of the way. All of that over the difference of squares, x squared minus 9. So we get to do a little bit of canceling in the numerator, not because we have something over each other, but because we're just adding and subtracting. And if we have positive x squared and negative x squared, they cancel each other out, and a positive 9 and a negative 9. But these middle terms, since they're the same sign, we have to combine them. And that's how I end up getting 12x over x squared minus 9. I hope that helps.